Hello everyone. I'm going to give you a very short introduction to what databases is all about. Let us get into the presentation. I'm Dr. Dijay and I'm an assistant professor in the Department of Computer Science and Engineering. So this is the overview of the presentation. We'll be seeing the introduction, the role of database management system, the terms and terminologies associated with database, the types of database, some of its features of database management system, what tree schema architecture is about, some of the components of database management system, a quick look at what SQL is and what are the design goals of a database and an example database, and then we'll be looking at some of the career prospects for DB professionals and what are all the database certifications that are available. Every day, data is getting generated either manually or automatically, and we need an efficient means to store and later retrieve data whenever we need it. Database is the solution for that. And with growth of internet over things, sensors produce lots and lots of data, and we need a place to store this data for later accessing it for some useful purposes. Database, as I told you, it's a collection of relevant records. All related records, say for example, student information. In a university, usually student database will be maintained wherein every details of a student will be preserved. So database helps us to organize all relevant stuff into a table. So next is the database management system. So it is actually a piece of software that helps users or the applications to access and manipulate the data and later generate reports from the data that is stored on the database. So we need to understand the underlying difference between the database and the database management system. Your database is just a container that holds all your data, and the database management system is actually the software that operates upon the database and helps us to access, manipulate, and generate reports. This slide shows you what is the role of database management system. As I told you already, database is actually a collection of records, and database management system is the software that helps to speak with the database. And users or the programmers usually communicate with the database management system via application programs or queries. And database management system picks up those queries, and it has necessary software to process the queries and interpret the meaning. Only after interpretation, the database management system will come to know what the user expectation is. After that, the software will help us in accessing the data that is stored on the database. And apart from the database, every database management system will have the metadata. Metadata is nothing but the data about the database. In other words, we would say that it is the schema. So whatever be the underlying structure of the database, that would get conveyed to by means of this metadata. For interpreting the queries and to access data from databases and to check whether any constraints that do exist on the data, it is necessary for the database management system to have a look at its metadata. This slide shows you some of the terms and terminologies associated with the database. You could see here a table. So the database, you could view it as a table. The other name for table is relation, and that's why we have given the name as a relational database. Every database which we are learning as a part of relational database, will be viewed as a collection of tables. So you could organize all your data in a set of tables, and every row in a table we call it as a record. So the record here you see here, what you see here is a customer table where the table has 4 rows, and we say that the table has 4 records actually that corresponds to 4 different customers. The other name for record is tuple, and every column in a database table we call it as an attribute or keys. And if you think of this table without the first column, that is customer ID, you could see that in the first record and in the last record the customer name is one and the same, and it poses some difficulties if all the other 3 attributes in the record are one and the same. We cannot uniquely access a record, and that comes the role of a primary key. So primary key is one of the columns in your table that will help you to uniquely access records from the table, and every intersection of a row and column in this table will hold a data value. Thereby we say that every cell will hold a value, and that value is going to be atomic, or we say that the cell is single valued. These are some of the example databases. We have some proprietary databases like Oracle database and Microsoft SQL Server and Microsoft Access, and there are certain open source databases, MySQL and PostgreSQL, and we have certain non-relational databases or NoSQL databases like Maria database and MongoDB, and we have IBM's DB2 as well. So these are all some of the example database management systems that are very frequently or used. Then about the types of data and database. Data, as we saw the previous example, we mean that data as the small data, the data that resides in a table or a relation. We usually call it as a small data. There are certain enterprises and organizations like Facebook, Amazon, which do actually generate incredible volumes of data 24/7. And such a data needs to be stored, and later users usually mine that data for extracting some useful information from it. Since such business data necessitates to make some recommendations or to make some predictions, we have some tools and techniques to process such high volumes of data, and we usually call that data as big data. Apart from big and small, we have data that is in unstructured format, that is not in the way as we see in tables. And we have semi-structured data also, wherein semi-structured means the data that is partially structured and partially unstructured. And when we speak about the types of database, accordingly you could have either a relational database, that is a structured database, or you could have even an unstructured data in NoSQL databases. And there are certain example NoSQL databases like Apache's HBase, Cassandra, CouchDB, MongoDB, and Neo4j. This slide tells us the features that are offered by a database. It offers help in minimizing the duplication and redundancy, and it helps in saving the storage space as well as the cost. It helps anyone to work on it, and it also supports multi-user access to the database, and it provides or offers higher level of security, and it helps in maintenance. This is the 3 schema architecture of any database. At the underlying layer, we call it as a physical layer. So physical layer, it is where your database is stored as tables, and every table you could view that to get stored as a file. So physically as a file, your database is stored in the disk structures, and that is what we mean as the physical schema. And next to that, we have the conceptual schema, wherein we view the database as a set of entities, and the relationships that exist among the entities, and what are all the constraints that are getting enforced. The speciality of the conceptual schema is it completely hides the underlying files in which your data is actually stored in the disk structures. So we usually perceive the table database as a set of tables and the relationship that exists among the tables, whereas we completely forget about the way it is getting stored in the disk structures as files. And at the top we have the external layer or external view, wherein the database can be viewed by different people in different ways. For instance, I could say that we have a view 1 and that is meant for user 1, and he is supposed to view only certain attributes from every table. I could generate another view for the same database wherein I allow the user to access all the attributes from all the tables. And I could even generate one more view on the database where my database has say 5 tables, and I project every 2 attributes from any of these tables. Okay, that I could call as view 3. So thereby every database management system supports this 3 schema architecture. This slide gives you a picture of what are all the components of a database management system. We have components like the data dictionary manager that helps to manage all the schemas of various databases, and we have query optimizer that helps us to optimize the query that is given by the user in terms of minimizing the disk access. And we have transaction manager, wherein by transaction we mean every operation on the database. We have command processor, integrity verification module, and then there is a recovery manager module. So in the event of any failure or in the event that the database has crashed, this module will help us to recover the database. And there is a buffer manager that helps us to schedule the disk accesses. So as a part of this subject, we will be learning about each and every module within the database management system in detail. About SQL. SQL is actually a database standard that is developed in early 1970s. It is the language by which we can communicate with the database. There are various types of SQL commands like data definition language commands, data manipulation language commands, data control language commands, and transaction control commands. So with data definition language, we mean that we can create the table, we can alter some of the attributes, maybe add a new one, or remove an existing attribute, or modify an existing attribute. We could even drop a table or truncate a table, wherein truncate in the sense removing all the rows from a table, and dropping means deleting a table as well as its schema together with it. So with both truncate and drop, we will not be able to recover back the database tables, and we could even rename an existing table. So all these are part of data definition language. And we have data management language, data manipulation language, wherein we could we have commands to select tuples from the table, or insert tuples into a table, update certain tuples, or delete certain tuples. And we have data control language, with which we can uniquely fix roles and responsibilities for users of the database. We can grant them some privileges, maybe to insert some tuples into a specific table, or to view certain records from the specific table. And upon granting some privileges, we can later revoke that privileges as well with the help of this revoke command. Then with transaction control languages, we have commands for commit, which means to permanently save the effect of transaction onto a database. And then we have save point. So save point is like we can set save points at different points of time for a database. Say, imagine that I create one save point at the moment your database is populated with 50 records, and after that, upon adding another 50 records, I could create one more save point, and with the help of rollback, I could even go back to the state of the database where there was only 50 records. So that for that purpose, we have commands like save point, rollback, and commit, and all these are associated with transactions. Having understood what database is, next we need to focus our attention into the database design. So before designing any database, we need to determine its purpose and collect all relevant information, and we have to divide the collected information into the set of entities in real world, and we have to map that entities into tables and turn the data into the tables. And upon doing that, we have to identify primary keys, and as we know earlier, primary key helps us to uniquely access records from every table, and we need to establish relationship between tables with the help of foreign keys. So by foreign key, we mean that the primary key of one table will be acting as a foreign key in another table, and that is how we establish relationship between any two tables. And after doing all these 4 steps, we normally proceed with normalization. So normalization is actually a set of rules that guide us towards maintaining a very good design. And upon doing this or following this normalization steps, your table will get refined. This is the database design goal. The first goal is to eliminate redundancy. Your table should not have any redundant values. So if there are redundant values in the table, that will always pose some difficulties at later point of time. And the second objective or goal is we always expect the database to be accurate, and we need to ensure its completeness. Let's see this with consider this example. You could see here there is a table with 5 records, and it corresponds to the customers, their address, their name, and what are all the products they have purchased, and the date in which they have placed the orders. And you could see here that in the first 3 records the name is duplicated. Okay, and in the third column you could observe the product's t-shirt has been duplicated. Right. So this the problem arises when in any one of the first 3 records, if I make a change in the name attribute, then that attribute will later introduce confusion or chaos. The system may get confused whether we mean the same person or they are 2 different persons. So we always say that your database should not contain any redundant values. And in order to do so, we need to follow some sort of normalization procedure. So you could observe here that only the attribute name and address correspond to that of a customer, and product is something different, and the order is something is different. So what we could do in order to eliminate redundancy is to split this table into 3. One corresponding to that of the customer, the other one pertaining to that of the product, and the third thing that is order date, we could isolate that to be a separate table. So if after doing this you could observe that the redundancies are completely eliminated. We have only 2 customers and we have 3 products, and the order date is going to be 2, and you could not see any duplication here. Having eliminated redundancy, now we populate more information with every table, with customers, with products, and with orders. We see that every table has a attribute called as primary key to uniquely access records from that table, respective table. Accordingly, customers table has customer ID, products table has product ID, and orders table has order ID. And we build relationship among these tables. So between customers and order, we establish relationship by taking this customer ID primary key into this orders table as a foreign key. And we create one more table named order details, where we preserve every order. And in that order details table, I have the primary key from the orders table and the product ID from the products table, right? So we have 2 attributes taken from 2 other tables, and they act as foreign keys here, and we call them as composite attributes because they are more than one attribute are used to fetch order details. Having understood the database design goals, let's have a quick look at the database carriers and job roles. So we have database administrator, database developer, and database analyst. So the role of the database administrator is to ensure the security of the database and to ensure a safer data access and to grant privileges for users of the database, using some of the built-in features available with every database management system. And they will be actually doing some sort of recovery procedure in the event of a DB crash or database failure. And we have database developers who will be responsible for designing the various database objects, that is tables. And we have the role of data analyst. They will be actually doing the twist and turn on the data that is stored on the database, and they generate data that is sufficient for making decisions associated with every business. These are some of the certifications that are offered by Microsoft. We have certifications at the basic, medium, and advanced levels. At the basic level, we have Microsoft Technology Associate and Microsoft Certified Professional (MCP). At the medium level certification, we have Microsoft Certified Solution Associate, and we have this certification for 3 different roles, that is for database administrator, database analyst, and database developer. We have MCSA Development, Administration, and Business Intelligence. And we have advanced level certification, that is Microsoft Certified Solutions Expert. And for doing this advanced certification, it is mandatory that we have any one of the MCSA certifications. Similar to Microsoft, Oracle also provides us various certifications like Oracle Certified Associate, OCA, Oracle Certified Professional, OCP, and Oracle Certified Master, that is the expert level of certification. So for OCA and OCP, we are supposed to clear 2 exams, and with OCA, they offer the basic fundamentals of SQL and the installation of SQL. Now to summarize what we have seen so far, we learned that database is a collection of relevant records, and database management system is actually the software that operates on the database and helps in accessing or storing data into the database and to generate various other reports. We learned that the table is also called as relation, and every row in the table we call as the tuple or the record, and we call every attribute column in the table as attributes or keys. And we learned also what primary key is and what foreign key is. And then we learned about the 3 schema architecture, that is how the database is viewed at the physical level, and the power of the conceptual schema, and the power of the external schema. And we learned about the various components of the database management system, as we are going to learn each and everything in detail in this subject. And then we learned what SQL is, structured query language, that is, it provides the means for communicating with our database. And then we learned about what database design is and what are its goals. Like, we need to minimize redundancy, and we have to ensure the data quality by means of ensuring the database accuracy and its completeness. And then we came to know what are all the certifications offered by me with respect to Microsoft and with respect to Oracle. And then we learned what are all the career prospects available for database professionals. Like, you could be, once you have mastered the subject, you could either become a database administrator or a database developer, or you can even venture into the field of data analytics. I have given you a very brief introduction to what database is all about. Thank you for your patient listening, and have a great day ahead.